Hey everyone, welcome back to the channel. Today we're diving deep into something that may affect millions of Android devices. But don't worry, we're approaching this from a cybersecurity research perspective to understand how this sophisticated threat works. This video will walk through you attack techniques including data filtration, screen capture, evasion methods, and even much more. Remember, this content is strictly for education and cybersecurity research purpose only, and never use this information for malicious activities. And to get started, just make sure that you got an Android device if you want to try it, or you can get the ISO of the Android and try to configure it. I gotta post some video that explains how to do it. I'm gonna leave it right under the description if you want to try it out. Or you can use other apps that you can emulate more Android device like Ray Motion. And let's get started. So, first of all, with the API key delivery, we're going to create an HTTP server running on port 8080 to host the malicious APK file named ape-debug-apk. This server is typically placed on the attacker's local network or a cloud instance, making the file easy to accessible the target device. And first of all, it starts with the installation phase. Once the user you can create an automated dropper, downloads the APK, the application is installed into the victim device. At this stage, nothing suspicious has happened yet, at least from the user's perspective. Then, at the phase of permission request, it immediately launched the main activity request, a broad set of dangerous permissions. These include access to contacts, messages, location, and even much more. Notice how the user conserves its pivotal without granting this permission, the attack cannot proceed. And first, it's going to activate the malware sequence. When the permissions are granted, the application triggers install malware sequence. This orchestrates the remainder of the malware's behavior. And then it activates the data collection. The data collection singleton gathers extensive of information: contact, SMS history, install application, hardware specs, network details, and even geolocation. And after that, its filtration JSON payload. The JSON is sent via HTTP post request to the attacker's controller flag C2 and server on port 5000, specifically to exfil JSON endpoint. Then it activates the screen capture parallel to the data collection. The malware requests a screen capture, resulting in image exposed to exfil screenshot, providing the attacker with a real-time snapshot of the victim's display. Then the command and control processing, the flag server, it passes the incoming data, logs and summarizes statistics, and stores the artifacts for later analysis. And then finally, the attackers, on this case the security research, reviews the exfiltrate information to assess the effectiveness of the attack, and that completes the high level overview of our malware workflow. In the next section that follow, we'll deep dive into each component, examining the code base and network traffic and stuff like that. Okay, let's look at the dramatically expanded permission set. First of all, up the user permission entry. This tell Android which system APIs the app can call. First, on this section, with internet, the app can reach out to remote servers. They'll let it see and even talk with your Wi-Fi or mobile data, perfect for C2 communications. The contacts and the SMS section, reading contacts and SMS lets the malware harvest your address book and intercept your or even exfiltrate your message. Grabbing call logs gives you insight into who you've been talking to. The location services section, find and calls location data can pinpoint your GPS or network. The background location means it tracks you even when the app is closed. The device information, it uh, this let it pull your device, SIM number, and any registered account. Great for unique IDs and lateral movement. On storage and media, it gives you permission for full read and write access to your SD card or even share storage. An easy way to drop secondary payloads or siphon off your photos and even your files. The system service, uh, foreground service, keeps the malware alive with persistent notification. The system alert window allows overlay attacks. The boot completed means it ought to start on reboot, and wake lock stops the device from sleeping. And the advanced permission, it gives you permission to use the camera and the microphone. It lets it spy on you visually and audibly, modifying audio settings, could hide recording beeps or even distort indicators. And they are administrative permissions. Basically, EU's package uses starts, let it monitor other apps' behavior using query all packages. It gives a full view of what's installed on your device. Then, on this section over here, uh, basically there are two entry points. The first is ported and shows up in your launcher. The second is hidden using exported faults like a covered backdoor or fallback screen. And by reviewing each permission and component, you can exactly how malware gains and maintain control. Alright, let's walk through the core of our Android malware runtime logic in main activity KT. First, when the app starts on using this function on create, wires up everything and then kicks off the main malware flow. Then on start malware sequence is a core runtime based pipeline that at random jitter to evade sandbox detects and aborts in emulators, pings the C2 server, and it triggers the dangerous permission dialog. Uh, then then we bundle up all the Android dangerous codes that we need. The permissions for read contacts, read SMS, the call logs, the location, camera, mic, and lots of permission. Then once permission screens fall, or even if some are denied, we proceed to collect device data, contacts, SMS, ID, location, and then we exfiltrate it as a JSON, then I request a screen capture prompt. On this function, when the user taps OK on the system dialog, we spin up a media reaction, visual display, and image reader pipeline. Each ring gets pushed to our X field sender routine. Now we'll dive into the true brain of our Android malware, the data collector. Uh, the singleton pulls together every bit of device data before its filtration. Uh, it starts with the collect all data context. It builds one big JSON object, calling each specialized collector in turns them stamps it with a timestamp and date. First, it grabs raw system and hardware specs, everything from Android version and manufacturer to the top lines. Uh, in this section of this function, collects this info and collect hardware info. Then on this section, it pulls connectivity status used through the Wi-Fi and speed all non-loopback IPs and even a SIM operator details when permitted. Then the collect install apps walk through every install package. For each, it notes the package name, its human readable level version, install times, system ads, flags, target, SDK, and even the full list of requests and permissions. Then they collect SMS and contacts. Basically, if the user granted contacts, SMS, or call log permission, we spin up cursors over the appropriate content providers and collect the top entries, name, number, type for contacts, and last 50 SMS and last 50 calls on this code. And with find location permission, we simply report which providers are enabled, GPS, network, and listed all of available providers, which get accounts. We enumerate every Google, Facebook, or custom account on the device in this section. Then the storage on the helpers. Basically, collect storage info. It checks free total bytes on our internal data and external SD card. Under the hood, we rely on harsh permissions, shortcuts, and get IP addresses. Help that loops every network interface for non-loopback IPs. And there you have it, a single orchestrated that gathers system, hardware, network apps, contact, messages, calls, location, account, and storage into one massive JSON blob, ripe for exfiltration. Next up, we'll see how the data actually gets shipped off the C2 server. And with that, we're going to use this file that the X field sender basically is a Kotlin singleton that manages all on-bound communication to the attacker servers. It initializes a single OK HTTP client with extended connect, read, and write timeouts to ensure reliability over slow or even unstable networks. We called to exfiltrate the data, it sent JSON routine launch on a background thread, wraps the harvest information as a JSON payload and issues a post to exfil JSON endpoint. It logs the HTTP status and server response before quietly returning control. Then for screen captures, we're going to use send screenshot. Also runs off the UI thread. It puts the latest image buffer from an image reader, convert it into a properly sized bitmap, accounting for an Android RAW right, compresses into high quality uh, the names of the file using a timestamp and send it as a multipart from data to Xfile screenshot. After the upload, it closes the image and recycles the bitmap to the free memory to avoid leaks. Before attempting any upload, Xfile sender can run test connection, which performs a quick get to the server root. It threads any response or even 404 as confirmation that the command and control is reachable, preventing wasting network calls. Finally, this is the C2 flag server starts by creating these three directories: executable data, executable data screenshot, executable data JSON data, to organize incoming files. Its root endpoint is a slash. It serves a simple HTML dashboard to that lists all received JSON. Um, then the status endpoint that returns a JSON object with the server's health if it's online, and timestamp accounts of JSON and screenshot file received so far. Then, when the Android malware posts to Xfile JSON, the server parses the payload, assigns it a timestamp file name, save it in under JSON data, logs a summary of key fields, the device model, the entry operation, number of ads, network info, etc. And it replies with a success JSON containing file name and the timestamp, similar to post in a multi-platform with a screenshot file to the slash x field screenshot on this section. Causes the server to validate the upload generate with a timestamp PNG name, save it into screenshots, log its size, and return a JSON confirmation. Then, basically, on this section, it's the download routes, the download JSON, the file name, the download screenshot, and also the file name. It allows directly retrieval of any saved file, and it also have a custom 404 and 500 handles, ensure that invalid requests return clean JSON error message without exposing the internal details. Finally, the server runs in debug and threads mode on the attacker's IP and port 5000, ready to accept simultaneous exfiltration requests and log activity in real time. And after that, let's try the malware, shall we? And finally, to run our malware, we just need to use python flag server.py and use Python HTTP server with the port 8080 to deliver our APK. Basically, this is the APK. We just need to download it. Wait a moment. Open it. Install it. Not suspicious at all. We just need to wait a second. Finally, the permissions going to start to ask us to get into the every section that we ask. We just need to allow everything. And if we go back to the file, or you can just go, there is some information of the device. It would say it's an Android 9 on the VMware Bureau platform. You can just go through this IP, open it to see what it got. It got two JSON files. Let's see. There is the system information, even my system information, as you can see. It will save the lots and lots of the applications that it's on the Android device. That's every single one of it. Settings, Bluetooth, dev tools. This section it will display the contacts, the SMS message, the call logs. Also for location info, right now it's false because I deactivated. It also will collect the Gmail accounts, and basically that's what it does the malware. In summary, this is the end to an end setup. Demonstrate a fully automated Android data thief pipeline. The app's main activity drives evasion, permission harvesting, data collection, and even screen capture. The data collector assembles everything into a single JSON blob, and that's the exfil sender. Then reliably ships both JSON and images of the device, and basically the Flash C2 servers neatly ingest, organize, display, and achieves each payload while it's powerful proof of concept or for red team and malware development training. Remember, always employ this technique only on authorized and ethical engagement, and never against unwitting targets. And this is the end of the video, and see you in the next week.
If you're passionate about malware and cybersecurity, I've got something awesome for you. Check out our academy focused on ethical malware projects. We offer a range of courses to boost your skills. First up, there's Introduction to Windows Malware Development for those getting started. Next, dive deep with Building a Custom RAT to create your own remote access tools. And for those wanting to analyze and understand malware, there's Introduction to Malware Analysis. But that's not all. We also have our Malware Development modules, mini courses that cover specific topics like evasion techniques. Join us and level up your skills